Welcome back to my channel Into the Oracleverse, where we learn about Oracle SQL, PL SQL, and Apex. Don't forget to hit that subscribe button. In this video, I'm going to show you how to use the native Boolean data type in Oracle AI database, which is available in Oracle 23 AI and 26 AI. We'll see how to create tables with Boolean columns, insert data using true and false, write queries using Boolean logic, use Boolean in case expressions, and applying the check constraints, and how to use it in JSON creation, and finally, how we can use these Boolean columns to optimize queries using the Bitmap indexes for high performance analytics workloads. First, I'll show you how to create a particular table with multiple Boolean columns. This shows how Boolean can now be used as a real table column type in Oracle AI database. The native Boolean data type has just two values in it, true and false. Means instead of this particular column, in the earlier version, so we have been or we would be using either a numerical column with zeros and ones or a particular varchar column with true and false values or yn values and things like that. But now with this, we have a standard which can be used to store these Boolean data. Now let's run this to create the table. You could see that the table has been created. Here I can see that the table has been created successfully with the relevant data types. Now let's move on to the next part. So first we will be seeing how to insert data, the Boolean data within the particular column. So here I have mixed the cases. You could see that this true is completely in lowercase and here it's in uppercase and here there is a mixed case. Still, if I run this, it will result in inserting the particular value. With this, we can conclude that it is case insensitive. And here you'll be able to see that the values are stored in a perfect way. Now, let's move on to the next way of inserting the data. So we can either insert the Boolean value directly, or we can insert it through an expression, which would in turn evaluate to a Boolean data type or a Boolean value. Here, you can see that 29 is indeed less than 50. So this should return true. And here, let me change this so that it will be evaluated to false. So is digital has to be false and the required shipping has to be true. Now, let's run this insert. And now let's see it here. And as expected, so the if digital is false and if request shipping is true. So this is one other way with which we would be able to insert the Boolean values within a particular Boolean data type column. And then we would be able to use the logical operators as well. So here you can see not and other values being used along with the expressions. So let me run this. And it has been executed successfully in request shipping column. So the value not 1 equal to 1 and 2 equal to 3 would be inserted. So 1 equal to 1, it would be true, and 2 equal to 3. So here the resultant would be false, and since it is not false, it is going to return as true. And here I can see that it has been returned as true. So yeah, so it's working fine as expected. Now let me just insert additional data for the demo purpose. There are two ways to query this Boolean data type to get the values which are true or false. So either we can apply it directly. So here we would be able to see the is available equal to true data set. So this is one way of doing it, but there is a simplified way where we would be just providing is available and is featured. So you would be able to see the values which are just true. This query in turn would result in the data set where is available and is featured are true. Now, not updated. So it is exactly opposite to this. So here we will be able to see all the values dataset which has the value of is available as false. So now we would also be able to use multiple Boolean logics in the same query. And here this should result in, yeah, so it's resulting in 2 rows. And I can, as mentioned in the previous examples, if it is equal to true, we can omit it. So this would result in the same data set. Now, using it in case when statements. So this is one another place where this would be very useful. We would be able to write the queries in a much easier way, which would be very easily readable. See, now I was able to write it in a very easier way. Which is, so here you can see that the query's length is minimal and it is very easily readable. Let's try updating the value. So similar to the insert part, we would be able to update it in a much easier way. So you can see that the row has been updated. So we can just provide true, false, or we would be able to use the Boolean values, or we would also be able to use the expressions which should result in a given Boolean value, and that can be directly be used in an update statement. And yes, now we can also use this Boolean check in constraints as a check constraint. So let me create a separate table for it. So it is user preferences. So I am providing a constraint where it is going to check whether the email notifications or the SMS notification has the true Boolean value. So this is added as a constraint here, and now we can test it here. So here you can see that the email notification is true, and this value should be inserted, and it is working as expected. Now this has the SMS enabled and this should also work as expected, and it is working as expected. Now here we are violating it because we are inserting the value as false for both email notification and SMS notification, which is against that check constraint. Here you would be able to see that the check constraint has been violated. So here we would be able to apply constraints in a much better way on the Boolean values, or on the columns which have the Boolean values in it. And now on to the most important part. So these JSON objects, so initially, since JSON is something that would be used by multiple applications, so there is a standard format for it. And to bring out or to generate this true or false value, initially we should have been using several cases and we should be converting it. But now with this particular update, things have become much easier. So here you would be able to see that the is available, and this feature and this digital has the Boolean values as expected in any JSON outputs. So it has become much easier with this given update. And now moving on to the one another feature that we have. So with this, we would be able to incorporate bitmap indexes on the Boolean columns. So before looking at it, let's see what a bitmap index is. So with bitmap index, we'll be able to index values which has distinct values, and the values would be stored as bitmaps or in bits. So here the expected values are just three. We are expecting either true or false or null values here. So with this, we would be able to improve the performance to a much better extent. Boolean columns are perfect for bitmap indexes in analytic workflow, and this is how we would be creating it. Now let's see. Yes. So with this, we will be able to fetch the values in a much easier way. Bitmap indexes transform Boolean column performance in Oracle databases. Now we have the bitmap index part. A bitmap index is a specialized database index that uses bit arrays or bitmaps to represent the presence or absence of values in a column. Instead of storing IDs, so this would store a compact bitmap for each distinct value in the index column, and it uses only 1 bit per row. This is best for low cardinality columns in which we can expect just 200 distinct values. And it is indeed perfect for Boolean, as we can only store three possible values: true or false or null. And we will be able to perform bitwise operations as well, the and, or, and not. And hence this would be a best match wherever we are introducing the Boolean data type columns. So if you are using this Boolean data type in your Oracle 23 or 26A database, bitmap indexes would automatically optimize the values in a much effective way. They are your perfect companion to Oracle 23 or 26A's native Boolean data type. Here we can see that those indexes have been created as expected. I was able to test it and I was able to see 97.4% optimization. This would be useful wherever you have the Boolean data type column, and wherever you don't have much updates taking place in that particular column, because it is not recommended for the tables where there are frequent DML operations taking place, because this might lead to bitmap locking. So that's pretty much it for today's video. So we have seen the native data Boolean data type in Oracle AE database, which makes our data model cleaner and which makes our business logic simpler and our analytics faster, especially when combined with bitmap indexes. If you're working with Oracle 23A or 26A DB, Boolean column should be your default choice for flags and status columns. Thank you so much for watching. If this video helped you learn something new or find what you are looking for, please give it a like. It really helps the channel. I'd also love to hear your thoughts, so feel free to drop a comment below. And if you are interested in more content like this, make sure to subscribe to the channel. Thanks for watching. I'll see you again in the next video.